Okay, let's begin now. So our topic is how to design duplex building in 2 hours using Staad software. Though Staad software is little, of course, many of us are more familiar with this Staad software. Still, we are trying to find out a path or procedure to make these designs done in a short period. So this is actually a picture of 3D model, a picture of this Staad Pro that we have on left side. Of course, this is a reference elevation. It is not the elevation of the same building that we are actually dealing with this currently. So how to design duplex building in 2 hours? So before knowing how we can complete this design, analysis and design in 2 hours, we have to know what is a structure, what is analysis and design, what are our final output generated, how much time it originally requires to complete it, and then shall we begin, right? The first thing is what is a structure, analysis and then design, what are the final outputs generated, and how much time originally it takes to complete this task and to perform this design, right? So let's now go to this structure, because this is the basic information one has to definitely know to get into this core information. So what do you mean of a structure? Everybody or many of us already know structure in the sense it is a combination or integrity of structural components like footings, columns, beams, slab, and then staircase. So combination or integrity of all these structural components is called structure. That's it. Very simple definition. So first we should know what a structure is. Structure is nothing but combination or integrity of all these 5 structural components: footings, columns, beams, slabs, and then staircase. What do you mean of analysis then? So analysis is nothing but understanding a structural behavior. So we have to understand the behavior of a structure by analyzing or by focusing on the analytical resultants. True analytical resultants. Analytical resultants would be in the form of moments and then forces, right? Analytical resultants would be in the form of moments and then forces. So we have to know the forces and then moments. So nothing but understanding or analyzing or getting these moments and then forces is called analysis of a structure. So moments usually would be in the form of bending moments and then twisting moment, 2 directions bending moment, 1 direction twisting moment, and forces nothing but 2 directions of shear forces, 1 direction we have an axial force. Very simple thing. So we know what structure is, we also know what analysis is. Analysis is nothing but understanding structural behavior through resultants, which would be in the form of moments and then forces. Moments again have been classified into 2. One is bending moment, second is twisting moment. Forces again have been classified into 2. One is shear force, second one is axial force. That's all. So if you can find out bending moments and then twisting moments, shear forces and axial forces, depending on the application or transferring of loads from element to element, slab to beam, beam to column, column to footing, right? So depending on the orientation of the elements and then depending on the loads or transfer to these elements, so there would be change in the resultants. In the sense, beam will have a bending moments and then shear force majorly, and beam will not have any kind of a axial force. Means it doesn't mean that it is having a 0 axial forces. Though beams are having axial forces very little, so those amount of axial forces would not affect our design. So that is why when we are studying about RCC designs during academics, we would have not focused or not considered this axial force during this designing of a beam. But during the designing of a column, we focus on the bending moments and also on the axial forces, especially for column designs. The same thing during the column design, we do not focus on the shear forces, right? Focus in the sense the impact or effect of such kind of resultants would be little lesser. So that is what to understand the behavior of a structure. So that is what is called analysis. So once we could know what a structure is, once we could know the different types of loads that need to be calculated and then assigned to this structure, then we will analyze this structure, get moments, forces, and deflections, and make sure all those moments and then forces are resisted by the structural components like beams and then columns especially, right? Columns, beams, slabs, staircases, foundation, every element is already existing in a structure. Every element has to be certainly designed to ensure that loads are properly transferring from one element to another element without getting damaged or without getting failed in any design criteria, right? Now I believe you understand what is structure, what is analysis, and then what is design. So design is nothing but finalizing the member cross section and provide sufficient reinforcement to resist analytical resultants. That's all. Beam design, nothing but we have to fix up the beam cross section and fix up the reinforcement that requires to resist the bending moments, shear forces, and to control the deflections. That's all. Column design also same statement. For column also, column should have enough cross section, and then it should also have enough reinforcement to resist bending moments and then axial forces. Same concept. Even for footing also. So footing size and then thickness has to be finalized, and also reinforcement to be provided in it to resist bending moments and then forces, like forces in the sense shear forces, one-way shear and then two-way shear. So there is a little change in the analytical resemblance when we compare from element to element. So when you just identify a change in the design procedure, that would be ultimate to fix up the member sizes very easily, right? I believe now it is a little clear to you to know what this analysis and then design is. Now let's go to this next slide. Now we know what analysis mean, what is the structure, what is analysis, and then what is design. What is our final outcome or what is our goal in design, right? Final thing is this. Finally, what is our outcome? Finally, what is our outcome? Our outcome, our output would be preparation of structural drawings. Preparation of structural drawing would be our final outcome. So before this, we should know this input. Input in the sense to make this structural drawings of a building, we should have a input details like architectural drawings, plans and sections, and then elevation details, MEP details. And then once that is done, then you will start analyzing and designing a structure by using any design softwares like Staad and ETABS. This information or whatever I'm saying right now would be very clear to you when you are going to next step or when you are going to the further structural details. So don't worry if something is still not clear to you. Don't worry, especially students who are currently studying BTech or BTech especially, right? You'll understand everything in next 15 to 20 minutes. Now we understand what is structure, what is analysis, what is design. Our final outcome is we have to prepare structural drawings. To prepare structural drawings, we need to get design output. To get design output, we have to analyze it. To analyze it, we have to prepare a model, find out these loads, apply loads appropriately on every component, analyze it, and then design it. Here's the next, before process. Before modeling and then making this kind of analysis and design, we should have had this structural, architectural drawings, elevation details, and then MEP details. Nothing but this is input, and the next step is analysis and design. And the next step is we have to focus on output. In the sense, we have to generate all these drawings, foundation layout, schedule of columns and then foundations, plinth beam layouts, floor beam layouts, staircase layout, UG sums, septic tank. All these drawings have to be prepared and to be given to a client for execution. These are our final outcome, right? And just imagine our title is like how to design a structure in 2 hours. But originally, which takes around, if a person is not having any kind of a design experience, and if he is having a little exposure towards using this Staad software or any ETABS software, they need at least 5 to 7 days time. Minimum they need to, even though they have a little experience, they need at least 5 days to 7 days of time to work on it and then designing it. Let me share you my personal experience when I was a beginner in a structural design. Trust me, I took almost 1 month of time to design only ground floor building. Now, when I just reminded and when I just recall what happened in my past, in the sense in my previous experiences, when I just recollected how I have actually worked on this structural design, the first incident was I was given with a ground floor building, very small building only. It was a electrical distribution room building, right? Which is I think 17.23 meters length, and then it is I think 7.23 is the width, and then 17.23 is actually the length of the building. 5.23, I guess 5.23 was the width of the building, and 715.23 is the length of the building. It's a very ground floor building which actually had been designed almost 1 month time, within one month time. So which originally takes hardly 1 hour or 1.5 hour time. So why I'm saying you is definitely you will take enough, a significant amount of time, as we are not having a basic knowledge or not having enough knowledge on the key area or on the key procedure, which is originally very same for every building. So if you are given with a designing of a 2 floors building, procedure will remain same. If we are given with a 5 floors building, procedure would remain same unless there is a limited changes in it. So you might require to add only dead load and live load for 2 floors building, maybe even for 5 floors building if it is not located in seismic zones. So what actually makes a difference to design a structure, or what actually requires to spend enough time or little more time to design a mid-rise buildings like 5 floors buildings need to be noticed. So when you are more familiar to design even 2 floors building, procedure would remain same. We have to just scale up procedures and we have to just need a little more time to design 5 floors building. So likewise, since every design that we perform is very very common, in a sense, very repetitive procedure. You just have to focus on the repetitive things, and then you always have to unlock the key areas where actually are taking significant amount of time to complete our task. If when we have a 10 tasks to design a building, it doesn't mean that a 10 task equally consumes or equally requires attention and then equally requires amount of time. So we have to focus only very particular areas or particular tasks, like two to three steps during the design are requiring more attention and actually take lots of time for designing it. So such key areas are now going to be discussed in next 15 to 20 minutes. Now the same thing what we have discussed in the previous slide has been actually pictured here. So to make you understand a little more, so designing a structure, right? Designing a structure is nothing but we have to verify and make sure the structure is more stable, and then structure is also having enough of strength, and then it is also satisfying the serviceability criteria, right? And then detailing, right? Detailing also. So stability, in a sense, we have to ensure that structure is stable in sliding, overturning. This stability criteria, if we just recollected how we design it or what kind of design procedure that we learned, if you just recollect it, and I'm sure that you would not have considered this stability criteria during analysis and designing of a building. But I'm sure you would have, you would certainly remember when I talk about sliding and then overturning, very immediate structure that comes to our mind is retaining wall dams. Dams and retaining wall cases, we always focus and majorly we focus on then overturning and then sliding. Whereas in the building cases, we do not. It doesn't mean that we don't require to check the stability, but I mean, it is not applicable to the structure. It is applicable to our structure also. But only thing is, since we have we are having a framework structure, having a columns and then beams connected integrally. So the stability of the structure is very huge when we compare with this retaining walls and then dams. And besides, retaining walls and then dams are meant especially to resist horizontal loads. Especially to resist horizontal loads. Let me say when we have a dams and the retaining wall like this, obviously this objective is to resist to support horizontal forces. So when we have a major impact due to this horizontal forces, obviously structure gets slided or gets overturned. So we need to compare the stability criteria where we are using, where we are not using. We are using stability criteria in the case of dams and the retaining walls only, where the structures are actually meant to support horizontal forces. This stability criteria is not actually being used in the case of the buildings where the horizontal forces impact would be very lesser. Horizontal forces impact would be developed in the form of wind forces or wind loads, and the next force is earthquake force, right? So those impact also little when you compare the horizontal forces effect for this kind of a dams and the retaining walls. So that's why stability criteria is not really going to affect building. That's why we less focus on studying this stability criteria during analyzing and then designing buildings. And the next thing is strength criteria. Strength criteria in a sense, and we should have given this cross section and enough reinforcement to resist the moments and then forces. Moments would be bending and then twisting. Forces would be shear and then axial. And then finally, we also have to ensure that, especially beams cases, ensure that it is deflection of the beam is within control or within permissible limit. And the cracking criteria, in a sense, we also have to ensure that the members are not getting cracked. This cracking criteria is more important, especially when we are dealing with water retaining structures. It can be sumps or it can be dams, right? Where a structure is actually dealing with water or in contact with the water. Cracking criteria is more important. Once everything is done, like designing of a structure is completed, and then every information, every piece of important information need to be detailed. Everything has to be so detailed through in the form of a structural drawings. So which should also be as per guidelines and details given in SP34 code book. If it is a non-seismic zone structure, if a seismic zone structure, we have to follow IS 1390 code book. So there are guidelines SP34 and also IS 13920 code book guidelines need to be followed when you are preparing structural drawings. Structural drawings will be prepared based on the final output, right? Final output like design of columns and then beams, right? Yes. Shall we now begin? So this is a very basic information of analysis design, and then what kind of a procedure that we use. So shall we begin? Shall we begin now to design it using Staad Pro? Shall we begin? Karthik, yes, Dhanush, iPad, Tyagarajan, Sunita, and then yeah, Ses. I request all the participants to confirm once. If I am little faster, I believe that you will little excuse me for making my conversation little fast, but I'll try to, yeah, make my speech pace little lesser. My intention is not to make my session so fast. My intention is to give you as much as information that I can provide you within this short period. Yeah, super response. Thank you so much. Let's move. So, overview contents for the next 1 hour session. So, introduction is already over, and then study on architectural floor plans. We have to make a short study on this architecture plan. When we are asked to design any kind of a structure, we directly should not jump into our structural designs. We certainly need to make enough study on this architecture floors plans so that you are actually enhancing your skills on analysis and design. Do not get confused when you are focusing or when you are paying attention towards reading of architectural drawings. Would certainly give you a great idea or certainly enhance your skills on analysis and design also. It doesn't mean that these two are separate areas, these two are interlinked. And then once you are given with these architectural drawings, then very next instant is you have to focus on the positioning of columns, where to keep columns, and then how to finalize the framing system, right? So a simple question is, it is not just my question towards to you, it was actually a question towards to me also when I was done with my education. After I was done with my education in the sense of graduation, Btech completion. So in my during my engineering, of course, I had actually designed, I think 6 floors or 8 floors building design. So after we are done with this education, are you enough confident that you can design a building on your own, even if it is a simple building like ground floor or ground floor plus 1 floor? How many of you are sure that you can design your structure on your own after you're done with your Btech? Even if it is a simple ground floor and first floor? No. Exactly, it is. Answer is absolutely. I am very happy for your honest response. So what would be the reason for not capable enough to perform and to design a simple duplex or a simple ground floor building? The reason here is we actually have not learned exact procedure with respect to this practical requirements, and whatever the way that we have learned, either it can be a software or it can be a theory or it can be any kind of a concept. These learnings are not actually fully matured stage learned, in the sense, for example, if I want to design a ground floor building through using Staad Pro, in our curriculum, in our profile, resume or profile, we mention every detail, like we are done with our education, we did so and so a project based on so innovative things, and then we mention like we learned so and so softwares like Staad Pro, ETABS, AutoCAD, and everything is pretty clearly mentioned on profile. But when it comes to perform, when it comes to show your abilities to perform any kind of a design, it'll be silent. The reason is the way how we learn is not the way how we learn. The procedure is not exactly fitting or not exactly matching with the procedure that needs a conceptual learning to use software and then to understand the theoretical concepts and make sure it is compatible, our assumptions are compatible when you are analyzing and designing the structure. And then we will start designing it and then get output. And based on this, some thumb rules are based on some theoretical concepts, right? So that is actually the original procedure to learn it. Since we are now not learning anything through practical mode or when we are not working on the live projects, so we in fact are not enough confident to design any kind of a structure, right? Now let's get back to this positioning of the columns and then framing of system also. The way how we are learning AutoCAD is also is in fact most pathetic situation. Like we'll go to institution, we will start learning AutoCAD. We'll be given with limited commands like rectangular, circular, so on so. We'll be given with some kind of a shapes, ellipse, and then triangular, some rectangulars, so on so shapes will also be learned, and then we'll also be asked. We'll be given with a paper which is having a floor plan of a building, and we asked to redraw it. So we'll just simply redraw it using commands that we learned it. That is not actually a conceptual learning. The reason is the originally when it comes to a practical challenge, you'll be actually you will not be given with any kind of architecture floor plans. You'll be asked to prepare a floor plan. So when a client comes to you, client will come with a input details like, sir, I'm having a so-and-so plot size. 35 feet is the width of the plot, and then 60 or 65 feet is the length of my plot. I'm having a plot with east facing, and my requirement is a duplex building or triplex building where I can have a kitchen, hall, and then one single bedroom. At ground floor, I need a open well staircase, and in the first floor, I need 2 bedrooms or 3 bedrooms with a with a sit out, and then last floor I need a open space, open to sky space. So on so is the actually a requirement of a client. So if you would have learned AutoCAD in this way, means based on the practical information or the practical requirement of a client, that would be certainly appreciated, and that is only the way to learn it. So we are actually learning only command-based learnings, command-based software learning. It can be a Staad, it can be ETABS or anything, right? So that's why we are a little fearful that actually such kind of things are actually holding back us. And in fact, such kind of things are holding us not to become a confident in designing a structure. We have to identify that, crack it, right? Now, such kind of things will also be clear to you in this next 1 hour session. So now grades of materials and then properties of sections. You'll come to know what do you mean of property of section, and then what do you have for rebar, and then AST combinations. You'll come to know each and everything. And then standard loads like dead loads and live loads only considered for these sessions, and tips for column size and beam sizes. And when it comes to this major line, like tips for columns and beam sizes, so people who already have learned Staad or any kind of a ETABS or any kind of a design software, design softwares, why are we not capable enough to utilize this software's learnings, right? The same thing when we are trying to design a building in Staad or any ETABS software, what we do is we actually have been taught, like, let me say here is a column, and let me say here is a beam, and we have to go to this command, create a node, add this node, connect it to this node. Is not actually a conceptual learning. It is actually you are trying to learn, or you are trying to inject the commands that we know it in Staad. We are trying to make a model. We are not designing it. Designing, the definition of designing is completely known to us, as we have discussed about it almost 15 minutes before. We come to know what is a structure, what is analysis, what is a design. So we know these 3 stages: structure, analysis, design, right? So the way how we are learning this software, technical software, is not exactly the way actually industry or market is expecting you to work on it. So when you are going to attend any kind of interview, majority of the people will have a lack of confidence for attending interviews. And it is easy to blame any kind of a system. In a sense, it is easy to blame learnings. It is easy to blame, parents. It is easy to blame any kind of a circumstance for not getting any kind of a job, or for not reaching or any kind of a goal that we set for, right? But we have to identify the major cause why we are not capable enough to crack an interview, why we are depending on someone to get a job, and what kind of skills are certainly required to become more confident on it, right? These are the major areas. So let me give you a little example also how we have to learn Staad or ETABS software. So when you are learning Staad or ETABS software, we start creating the same thing. The entire information or the input details, input details need to be given to you, or in fact, output details given to you. In the sense, you are already given with a plan and located column positions also. Now you are asked to prepare a model exactly based on the details which are already given, which are already done and given on the paper itself. So the supposed to be supposed to be done by you. When you are required to prepare an architectural drawing, you have to prepare an architectural drawing based on the input details or based on the requirement of a client. So client will come to you and ask you to prepare a floor plan. That's it. Client will not come to you with a finalized or with a reference drawing to you. He never come to you. He always expects you to show your skills by accommodating every of his requirement, right? So that is actually the practical situation. Whereas when you are learning, we are already given with a drawing. When you are learning AutoCAD, given with a drawing, and we will be asked to prepare it and redraw the same thing in AutoCAD. We will redraw it, and we believe strongly that we learned AutoCAD. Technically speaking, which actually counts only 5% of learning. Not even a 5% of learning when you are comparing with this industrial requirements or market expectations from you. And the same thing for Staad or ETAPS also. You'll be given with this architectural plan by mentioning this column positions, column orientations, and everything, including column sizes. You'll be given with the column size also. You'll be given with the column position also, given with the column orientation also, given with the grade of material also, whether it is M20 or M25, and everything is given to you, which is supposed to be done by you, which is already given to you, right? So you take this information, start creating the same thing, create a node, create a column, and then use this beam creation options and create member creations, plate creations, and add everything. And you already have been given with the load also. You take this also load. We do not understand how we have got this load, how to calculate this load, and where this load, what kind of intensity of this load. Such technical concepts are not revealed to you. So we create a model and we will apply some load which is randomly given to us. It will be asked, okay, let us consider 20 kN per meter. We will take that load. And let us say floor load of 5 kN and 10 kN. We will take that load. We do not understand what kind of a load it is, how we have calculated this load, how this kind of a load is given to us. Such is the key information which supposed to be calculated by us, supposed to finalize the column portions by us, supposed to finalize the member size by us, and take the grades of materials by us, model it, calculate the loads, apply on it, make loads and load combinations, analyze the structure, run the analysis, analyze the structure. If member is failed, design it, member is failed, redesign it, and then when you are finalizing the member cross section, focus on the practical requirements. You might be restricted to fix the minimum column width or maximum depth. Such conceptual learnings are actually originally missing. Since such are missing, we are not becoming confident enough to deal with the structural designs, right? Such things also will be clear now. So that actually is going to be covered under these tips for column sizes and then beam sizes. And the next thing is Staad Pro. We go to this Staad Pro. We use such commands, and then we go to this thing, output. Output is make sure that every column, every beam is passed in it. And we also do not question why we are not making a model of slab in Staad Pro. We always create a beam, slab, apply load, run analysis, design it, and we say it is done. How do you say it is done? Because there are 5 components in a structure: foundation, column, beam, slab, staircase. Then why are we avoiding designing the rest of the 3 elements in a structure? We always focus only on column, beam. What happened to slab? What happened to this? What happened to the design of a slab? What happened to the designing of a staircase? What happened to the foundations? When are we going for a isolated footings? When are we going for a stepper footing? When are we going for a trapezoidal type of footings? When are we going for a lift footing, combined footings, raft footings? So what is happening it? Can we really design such foundations also using softwares? Or if it is not really so, what kind of a softwares will be really required to design that? Such enormous enlisted questions are actually creeping our mind before becoming a structural engineer. Nice. Today's content is anyway here. Now let's get into the reading of architecture floor plans. As I mentioned before, when we are given with the designing of a structure, we should not straight away jump into this to design a structure. We have to study architectural floor plans. First, make a brief study on architectural floor plans. So studying of architectural floor plan. What do you mean after studying this architectural floor plan? Once you are done with your education, obviously people will ask you, what did you study in your engineering? What is that? What are the different types of subjects that you have learned? What finally have you learned? What kind of a subject actually makes you more interested to build your career on it? Such questions are fundamental questions once you are done with your education. Similarly, when you are going to design or before you are going to design, people will first ask you, what kind of a structure it is. He'll say it is a duplex building. Okay, we are happy. At least you mentioned like type of building. Do you just be silent with that basic information? No, you have to always focus on every area. Like face of the building is east facing, building size is like a G+1 floor building, and then plot area, plot size is 36 feet 6 inches by 55 feet. So whose plot area is like 2000 square feet nearly, and then which is converted into cents. People never ever be silent. If you can just answer one question, you'll be given with 5 questions. If you are answering 5 questions, you'll be asked 10 questions. So that is why you have to always enrich your knowledge in multiple dimensions. When someone is asking you what would be the plot size, if you say like 36 feet 6 inches by 55 feet, they won't be silent. They'll ask you how many cents it is. You have to say 4.5 cents or 4.6 cents. They won't understand. What do you mean of cent? I need to know in terms of square yards. So you have to say in square yards. They won't be silent. Some people will be comfortable with square meters. They will ask you how many square meters. So that is why such kind of unit conversion also need to be learned very effectively. These are all more important areas that you need to answer in the sense you need to know it when you need to become a complete engineer, right? If you can know, what I strongly believe is, if you really know what to learn, I'm sure that you are ready to learn, right? I'm sure you are ready to learn. Whatever is required, you are ready to learn. But only thing is, many people who are actually learning it, who are actually teaching to you, are not knowing what is important to your market, or what is important to build your skills, or how to build your skills, how you are going to improve your values in the sense, value of your services. So one would be given with 10,000 rupees of salary, one would be given with 18,000 salary, one will be given with a job of 35,000 salary, and one will be given with 50,000 of salary. So what actually makes a difference from one person to another person is their skills. Their skills are nothing but their value. That is their value. So if you are increasing your value by improving or skilling up, by improving your skills, or by just making a skill up, right? You are improving your values, increasing your value. Not values, it's a value. It's a value, right? So it's your salary or it's your earning ability. So your earning ability depends on your skills. Your skills are depending on your learning. Your learning is depending on the process or procedure and the content that you are supposed to learn, right? If you are sure what to learn, how to learn, I'm sure you are ready to learn. You are ready to learn, to spend your time. You are ready to learn. You are ready to spend you are ready to invest a little financial things and everything to improve your skills. But only thing is, the major defect is, people who are teaching or people who are learning are actually not knowing what to teach, what to learn, to build their skills, to build a nation or whatever, right? So that is that's where we need to make little connection. That's it. Otherwise, we have enough opportunities in civil engineering, and we can make wonders also in it. I can show you that in some time now. Now, next thing is, we should know slab size and then slab area, number of slabs we have, total slab area we have, floor to floor height is like 11 feet 6 inches. Everything is like a question. Why I have to maintain only 11.5 feet? Why not it is 7 feet? Why not it is 10 feet? Why not it is only 6 feet? Such questions you can definitely, for such questions, you definitely need to have an answer, right? And then the staircase type we have is open web. So what I'm saying is, when you are asked to design a structure, directly don't jump into this structural design. You have to focus only on reading of architectural drawings, on especially basic information, type of building, spacing of building, size of building, plot area, conversion into different unit system, slab area, number of slabs, and then number of floors you can say, and then floor to floor height. Such information is also must be known to you before you are designing a structure. Now let's enter into this architectural floor plan details. Now this is an output that we have a architectural floor plan details. So this is a ground floor building and this is a first floor building. It is called a duplex. So duplex is nothing but 2 floors. Simplex is nothing but ground floor. Triplex is nothing but 3 floors. Simplex, duplex, triplex. Simplex, duplex, triplex. Simplex, ground floor. Duplex, 2 floors. Triplex, 3 floors. Right? It is a 2 floors building. And when you mention it is a duplex, this is staircase is provided within this building. Inside this building, staircase is provided. Right? When you say it is a 2 floor, not every 2 floor building will be a duplex building. So if you have a staircase provided outside, it is not a duplex house. It is a 2 floor building, but independent house. Independent independent house, but 2 floors. When you're having a staircase inside this building, it is a duplex building. And now I want to make a little correction here, in a sense, little understanding. So it is a east facing, car parking is provided. And then here in the ground floor, we have a kitchen, puja room. And this is what is called drying. Technically, it is called a foyer. Foyer in the sense, there is actually a space limitations also. We do not everyone to come home and we do not allow everyone to come and get into this or personal bedroom or private space, right? So very similarly, we also allow people like close relatives inside this wall, and some more little close relatives can go to the stairs. Some more close friends or someone can just get into this area also. So there is a privacy sensitive areas, right? So we allow people. So for example, someone wants to just come and then meet you. We'll just allow them up to this stage, which is also called a foyer or drying area. We'll ask those people, they'll come and then sit with you within this space, and everything is hidden in the sense it is not this entire space of living is not visible to this guest. So they'll come and they'll speak to them, they'll go out. That's all. So this is what is called foyer, and then this is a double height. Double height in the sense we do not have a slab here at this ground level, no slab at the ground level. So this is what is called double height. And here we have a duplex staircase and a puja here, kitchen here, utility area, and then we have a storeroom here. And this bedroom is a single bedroom that we have actually planned and in the ground level. So this single bedroom size is very huge. They're like 16 feet 6 inches and then 13 feet. And moreover, we are not keeping any kind of a wardrobe. We mentioned like wardrobe here, but there is no wardrobe. It is a clear space of a bedroom. And here we have a dressing room. So here we have a dressing room, and then toilet size is here. That's it. So toilet size is a very huge, like 8 feet. And then 8 feet by 13 feet is a toilet size. Generally, if you can notice, if you can try to get back, if you can try to get, if you can just recollect this sizes of the toilets at our home, you just can notice like around 4.5 feet or something. Even if it is like apartment buildings, like 4.5 feet, and then 5 feet would be the width of this restroom, and then length would be around 7.5 feet, 8 feet. That's it, usually. So since it is a little luxurious, so we change it's a toilet room sizes also. So little luxury, it is not a most luxurious plan, but it is definitely little luxurious. The same thing for this work floor. And it is a kind of a opening we have. So we have a very large opening here. In the sense, ground floor will not have any kind of slab. So people will come to this first floor. They cannot go this way because it is completely opening place. So we'll come to this place, and here, of course, they'll come to this place here. And next they can go to this bedroom or go to this bedroom. They cannot go to this because it is cut double height, right? And they can go to this gym and then meditation hall. They'll go to gym and then meditation hall, and then dress changing area also. And then can go to this area. This is the terrace, right? They can go here and then they can relax sometime here on the terrace, get back here and then go down to this, and then down. People are here again, they can go, right? So this is what it is a floor plan. So they're preparing this even to make this kind of a, to prepare this kind of a plan also, people will take at least 10,000 rupees. So that's why on the brochure we mentioned very clearly, you will be given with 25,000 worth of documents, right? Even getting this kind of a, especially in AutoCAD or editable format, we are sending you this in editable format. So you can use this. It is a real-time building only. You can use this for constructing it, or you can use this for your mini project or major project, or you can use this if you are a consultant. You can also, it will be best for you to use it when people are when clients are approaching you with the same requirement, right? So that's why we are actually sharing this core data. And here we have again same ground floor and then first floor. So here you can see this is the width of the plot and length of the plot, and this is the length of the building, and this is the width of the building. This is setback here, setback. Setback is nothing but distance from the face of the building to the plot boundary. Distance from the face of the building to the plot boundary is a setback. So we have a setback of around 2.5 feet on almost all sides except front. Means here we have a 7 feet setback, and car is accommodated here, right? Though this is a ground floor and this is the first floor. And if you can just see these column positions, we have a column position like this and this and this. And now the question is the same thing. How could we finalize the column positions, right? So for column positions, there are some guidelines. Those guidelines will be shown to you in the next 2 to 3 slides. After 2 to 3 slides, you will notice the column positions guidelines, column orientation guidelines also. You can go to them. Based on such, we have decided this column positions and then orientations. So this is the way of learning effectively. And now let's go to the next. And this is a ground floor again. Setback on 3 sides is like a 2.5 feet, 2.5 feet, and then 2.5 feet. East face it is 7 feet setback. So we have a 7 feet on the east face, east side. Yeah, this is actually the floor height. So let me say whatever the kind of boxes here. If someone is not familiar with the Staad Pro, they cannot understand what this is. For someone who is little familiar with the Staad Pro, they can understand that this model is this picture is from Staad Pro. So to make you understand, we have intentionally captured this picture and then shown you on this screen. So this is what is, let me say this is a ground level. This is a ground level. Below ground level, we'll have a column, and below this column, we'll have a foundation. So these are the foundation level. So we can say it is like foundation level. So from this ground level, you can say from ground level, this is like 7 feet below ground level. And then the plinth level is nothing but the tie beam level above ground level or even at the ground level also. We'll intentionally go around 2 feet higher. For example, now let me say it is a ground level. So we always take a height of the building around 2 feet, because when rain comes, so this stagnated water should not enter your home. If you're not allowing, or if you don't wish to allow this rainwater stagnation, so obviously your floor level should be little higher than the ground level or road level, right? So that is why this should be usually 2 feet height. Usually would be 2 feet height. So that is why plinth level we mentioned like 2 feet here, and then floor to floor height is like it is 11.5 feet height. Floor to floor height is 11.5. So 11.5 plus 2 feet, because we are mentioning levels now. 11.5 plus 2 is 36.5. 36.5 plus again 11 feet 6 inches is 25 feet. 25 feet plus 9 feet only. This height is only 9 feet. So 25 plus 9 is 34 feet. 25 plus 9 feet is 34 feet. So why did we consider only 11.5 feet, right? Technically, some people can also go for like 11 feet. Some people will go around 10.5 feet. But going less than 10.5 feet is not recommended. Going less than 10.5 feet floor height is not recommended, because there is a slab thickness and there is also a fan height, and then we have a cot height. And if you just stand on the cot, you should have enough space. Not only this, and you also are going to have a kind of a false ceiling. False ceiling designs, right? There is a false ceiling design, and there is a fan, fixing a fan, and so on, so things. So considering all these things, it is advisable to have at least 11 feet height. Having 11 feet height is absolutely fine. So having more than 11 feet, like 11.5 feet is also good. But it is not for the mid-rise buildings. It is for only 2 floors or 3 floors building. If you are going to have like 12 feet height, if you go higher for 12 feet height, again it becomes like uneconomical. But 12 feet height might require for some hospital buildings, where actually it requires additional equipment below the slab. Additional equipment in the sense, additional services arrangement, like firefighting system. Firefighting system will be provided within these commercial spaces or this kind of institutional buildings, right? When fire comes, obviously a firing system will actually firefighting system automatically will be activated, right? Sprinklers, example is sprinklers. Sprinklers have to be turned on their own and then sprinkle the water, right? So that depending on that, we have to fix up the height of the floors. So for our case, it is like 11.5 feet. Yes. Now column positions and then column orientation. Column positions are here. Column positions guidelines are given here. How do you position the columns? The column position is, first thing, all corners of the building are structured. They have to keep columns on all the corners of the building. First point. Next, if there is a staircase, ramp, lift, you provide 4 columns on the 4 faces, 4 corners, right? Third point, column to column distance not more than 20 feet. Try to make sure column to column position is not more than 20 feet, right? If it is more than 20 feet, which requires additional attention. If it is going more than 20 feet, you need to pay attention during design. When you are taking a decision on finalizing the steel, you have to pay more attention. That's it. So column to column distance usually not more than 20 feet. So which is not actually mentioned in any of our theoretical textbooks, right? Theory is not mentioned, but still. So we have to learn it based on this general practice. Next, we have to provide the column positions and intersection of walls. Next, expansion joint locations, right? Now considering all this first 3 to 4 things, you can just see this. All corners of the building, lift or staircase, column to column distance not more than 20 feet, and then intersection of walls would be fine. Now let's get back to this. Corners of the building. This is one corner, another corner, another corner, corner, corner. All corners of the building, right? All corners of the building, you have provided corners. Next, corners of the lift and the staircase. You have no lift, and then next is staircase. Corners of the staircase. This is the corner. This is the corners. Technically, this is also corner. This is also corner. But we have intentionally avoided this because if you can keep here, of course you can keep even here also. You can avoid this and you can keep here also. Either of the cases are absolutely fine. But we have provided here, right? Because if you can keep here, so there is no beam connectivity. So we are keeping here so that this beam also will be connecting to this point, right? So either you can keep here or you can keep even here also. But it is little recommended to keep here because there is a beam connectivity to this point. So you keep here and make sure the same thing is also available on the first floor also, right? Now we know this is clear. This is clear. Corners of the building, corners of the building, corners of the building. Staircase, this is clear. This is clear. Agreed. Third point. Intersection of walls. Where to keep? If you can keep here and then here, so where should I need to keep? Next column. Should I keep here or where? So that is actually depending on the third point, which is intersection of walls. So here I have a wall like this, and here you have one more wall. So this is the intersection point. Here I have a wall, and here I have one more wall. It is intersection. Keep one here, one here, one. This is anyway corner. And why not here? If we can keep here, so this column is very close to this column. Try to maintain at least 12 to 15 feet minimum gap. Try to keep 12 to 15. If we are going to have a column position within 12 feet, that won't be economical. That won't be economical. Unless until it is more important to have it, you can have. Otherwise, it is not recommended. Right? Now I think it is clear why we are keeping columns here. Intersection of walls. Not only this, even for this column also, intersection of wall. It is intersection. Even here also intersection. So there is a wall here and then wall here, intersection keep here. Now the question is, why do we need to provide a column at the intersection of walls? There are two reasons. The first reason is you have to, wherever we have a wall, you have to provide a beam. Beam needs to be connected to the column. So better keep column at the intersection of walls, because under the walls, beam is required. Beam certainly need to be connected to the column. So intersection of walls is recommended to keep a column. First point. The second point is, if we can keep column intersection of the walls, then we can avoid its presence, right? We can avoid its presence. We cannot keep column here now, center of the building, or we can keep column center of the hall, right? Which actually disturbs, which actually occupies this most precious space, and which actually disturbs the vision, right? So for having a position of columns at the intersection of walls, there are two reasons. The one reason is here exactly at wall locations we have to keep a beam. Beam needs to be connected to the column, so keep column. First reason. Second reason is, when you're keeping a column, try to avoid showing this. Avoid its presence within visible areas, right? If we can keep column here, nobody can recognize its presence. So we'll have a pleasant view we can have, right? So now we know this one, 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 also this one, because intersection, right? And this one is also known, this one also. Now we know why we are keeping the columns at these particular locations. Now the next question is, some people will have a question, sir, why not we have a column even here also? You can keep here, or when you keep here, now the distance between these two would be very lesser. What is the necessity of having one more column here? Because we have very close column here also. So better we should not have a column here. Keep column here. So that the beam point resting on this point, beam resting this point would be fantastic. So we'll have a column here. So we can have a connected beam here, and this beam is going to rest on this point, which would be absolutely fine, right? So this is another reason. Now we know all these columns positioning, the reasons are in fact guidelines for keeping these column positions. Fine. And next is here. Now why are we keeping this column here and then here? So absolutely. So when you are running this beam here, somehow this beam also needs additional support. So though now the distance between these two columns is a little lesser, we need to provide this column because we are not left with any other option. We have to keep this. If we can keep this column here and the column is here, and now we are going to run this beam like this and run like this, right? Now this beam would be suddenly resting on this column, So now the beam becomes more stiff, and upon this beam is going to rest. This beam's resting point is nothing but a point load that we are studying in our academics. This is actually act like a point load on this beam. And even here also, you'll have one more beam resting on this beam, and this beam is actually being rested on this point and this point. So keep here also. So they are the basic concepts that we have to consider for fixing up the columns. Now I want your quick response if this discussion is clear to you. Can you please make a quick response if this discussion is clear to you? I request everyone to give me a quick response if the discussion is clear. I request everyone to make a quick response if the discussion is clear. Narendra, actually raising your hand, I definitely will allow you to ask your question. Meanwhile, I request you to write your question on it. At the end of the session, in next 30 minutes, I'll certainly ask all of your doubts. You can ask me your doubts. I'll definitely respond to all your questions. Thank you so much for making a quick response. There are many people, and thank you so much. Thank you so much for your great response, Mr. Narendra. I'm noticing, I'm actually going to note down your name also. At the end of the session, I'll ask you. Meanwhile, request you to write your question on a paper. Ask me at the end of the session. I'll get back to you. Where is the fourth column for staircase? Can we see? Yeah, you'll see. Yeah, these two questions will be definitely answered. Where is the fourth column for staircase? Can we see? Yeah, you will see in 3D model. We are now going to open our 3D model. You'll see it. Mr. Arfan. And a second, Dhirendra Prasad is saying, why can't we eliminate columns at storeroom and the toilet corner? Is it possible? No, we have to have here, as I have explained, here and then here. If you avoid it, so this beam is going to act like a cantilever, and this is going to rest on it. Right? This entire load is going to transfer on it, and this now beam will act like a cantilever if you do not keep this column here. So we have to avoid cantilever, especially more than 6 feet, and especially another beam is also going to rest on the cantilever projection. It is a cantilever, and this is going to act on it. Then this effect of this load on cantilever beam would be most, we can say, give you maximum damage to the element. And the same case even here also. So this would act like a cantilever if you don't have this column, and this beam is going to rest on it. Then this cantilever beam would be more affected. Yes, now let's go. We know this. Next thing is we have to focus on the load calculations, and load calculations, though we have a different loads like dead load, live load, wind load, seismic loads. For this session and for this particular webinar, a short session, we are considering only gravity loads like dead loads and live loads only. So there are codal provisions. Intentionally, I have added these details, especially for the people who are currently studying BTech or MTech. So they need a little information like how to calculate these loads is actually based on some particular code books. And those code books list is also mentioned here. IS 875 1, 2, and then 4. Wind load is IS 875 part 3, and then seismic load is this. However, we focus only on the dead loads and live loads for this shortest session. We'll see that session. We'll see this calculation of dead loads. And before knowing this dead loads, you should know the densities of materials. Like RCC density is this much, and then brick wall density is 20 kg per cubic meter. Density of brick wall is, if it is a lightweight brick, it is like 6 to 8 kg per cubic meter. And then height of wall, as we mentioned, height of the floor is 3 feet 3.5 meters. Height of wall is 11 feet 6 inches, which is equal to 3.5 meters. So we are deducting beam depth, and we can have clear height of the wall is like 3 meters. Clear height of the wall is 3 meters. Let me say I have a wall here, and of course below this wall we'll have a beam also. We'll have a beam here, and then the wall is acting on it. Above this wall also will have a beam like this, and again will have a slab like this. So when this slab height from this point to this point is 11.5 feet, which is nothing but 3.5 meters. So wall height doesn't mean we will respond, Mr. Narendra. I'll certainly respond in our question. Right, I'll definitely respond on it. So now we know this floor to floor height is like 11.6 inches from here to here. And we know this column depth, beam depth is also here. We have to avoid, deduct this column beam depth so that it will have a clear wall height. So if you want to make your calculation more effective, so you have to deduct this beam depth and find out clear height of the wall and then find out the wall weight. So in this case, I just made it a little conservative. So I took like direct 3.5 meters height of the column, height of the clear wall. So now we know thickness of this wall is at 230 mm, and then density of the wall is at like 20 kN per cubic meter, right? Mr. Nagarjuna, we will talk about everything like a floating column concept. Yeah, we will discuss about it, but I request the participant to post a question which is relevant to our current session. And if you have still questions, though it is not relevant, I'll definitely, though not relevant to this current topic, I'll still respond to it at the end of the session, right? We have a challenge that we need to finish it in next 30 minutes. Let's fix it. I know, I strongly believe that we have willpower. I also believe in myself that we have a willpower. We will finish it in next 30 minutes, right? So now we know this thickness of the wall is 0.23, nothing but 9 inches. Density of brick wall is this, and height of wall is this. Multiply the thickness, density, and the height of the wall, you'll get load like 16 kN per meter. So when people are learning Staad Pro, they'll be directly given with the so UDL and they'll apply it on it. So it is not that you have to find out what kind of a load it is, how to calculate this, and apply it appropriately. So 16 kN per meter is the load due to external wall. 8 kN per meter is another load, which is the internal wall, which is half of the external wall. So load will also be half of it. And then parapet wall height is only 1 meter. So you'll get like thickness is same, density is same, height changes. So obviously load changes to 4.6 kN per meter as parapet wall load. Now we know loads also. Now let's recollect what we have discussed. We discussed about what is a structure, what is analysis, what is design. And we discussed about column. We studied this architectural details like the building type, building size, plot size, slab size, setbacks, and then areas conversion into different unit system, cent, square yards, square meters is now discussed. When that is discussed, next step is you have to focus on the column position, column orientation. We discussed about column position. We'll discuss about column orientation then in next 5 minutes. So column positions, we have guidelines, like we have a guideline for column position. Column position, corner of the building, and then the corner of the staircase or lift, and then intersection of walls. That's it. Based on these 3 guidelines, we have fixed the column positions, but not the column orientation. Column orientation we'll discuss in some time. And next step is with this discussion of positioning of columns, we have gained a little knowledge on preparation of model. Next, modeling preparation is done. Then you have to calculate the loads. That's why now we are straight away discussing about the load calculations like dead loads and live loads. Under dead loads, we have to talk or discuss about external wall and then internal wall. External wall thickness is 9 inches at 230 mm. Internal wall is half of external wall thickness, that is 115 mm or 4.5 inch. Accordingly, we have estimated the load. Right now, the dead load is over. Next is slab load. So slab load, actually majority of cases, the slab thickness would be only 5 inches, nothing but 125 mm. So you know the thickness and you know the density of concrete, you'll get like 3.125 kN per square meter is the dead load, right? Dead load of the slab. And the floor finishes, nothing but tiles that we are actually placing on upon the slab would have a weight like 1 to 2 kN per square meters. It is a depending on the material that we are using. Some people will use only tiles, some people will use marble, some people use granite also, right? Some people, in the sense, especially for commercial spaces, people will prefer marble or granite. So when there is a change in the finishes material, obviously load will change. So when load is changing like from 1 to 2 grams, you have to take it accordingly. So let's take it on conservative side like 2 kN per square meters. So 3.125 is only slab thickness upon which we have a tile or marble or granite. So for which we are taking 2 kg per square meters. Total is 5.125 kg per square meter is the slab load. Next is staircase load. Staircase load we will discuss when we are applying on the model, right? So that will become more clear to you. For now, we are not talking about staircase load. We will discuss it when you are preparing a model and we are applying on it. Now for live loads, so we have to straight away take live load like 2 kg per square meters for typical floor. For corridors in the storeroom, you need to take 3. So yes, though code is suggesting to take different loads like 3, 2 or so on so, especially when you are performing this quick designs, like designing them 1 hour or 2 hours, we cannot make, we cannot do, definitely we are deviating accuracy level little on conservative sides, right? We are focusing, we are actually deviating this accuracy levels a little, right? So that's why though code has given like 2 kg per square meters, 3 kg per square meters and so on so, either you can take 3 on entire area or you take only 2 on entire area, because application of 2 kg per square meters would be more on floors rather than having applied only 3 kg per square meters, because storeroom size is very lesser. You have to take 3 kg only for storeroom. Rest of the majority of areas you can take only 2 kg per square meters. So that's why you can consider only 2 kg per square meters and then you can design it, right? 1 second. Yeah, now let's go to the next Staad model. Right, we have prepared a model. In the sense, we discussed about architectural drawings, structure, analysis, design, column positions, and then some suggestions on it. Next is column standard column sizes. Usually, this would be the still standard column sizes. Begins with 9 inches on one dimension, and this dimension will change like 12 inches, 15 inches, 8 inches, 21 inches, 24 inches. This remains same. 9 inches remains same, and this is changing. These are the standard column sizes. So when you are learning Staad Pro in the institutions, we will take like you take some so on so column size 230 by so on, 250 by 300. You take like 230 by 450. You take like 250 by 400. Such column sizes before you are choosing them, you should know why you are choosing such. So you should not select some random number for fixing of the column size. So for column size fixing, you have to begin with 9 inches width, and then depth may be 12 inches or 15 inches or 18 inches, which is in fact incremental of 3 inches, right? Incremental of 3 inches. So the 9 inches, the reason for having a 9 inches width is, it is depending on the beam width. Beam width is depending on wall width. Wall width is depending on wall brick size. So brick size is actually 9 inches, 4 inches, 3 inches. 9 inches, sorry, 9, 4, 3. Brick size is actually 9 inches by 4 inches by 3 inches. So brick size is 9 inches now. You have to keep beam size 9 inches. Beam is 9 inches now. You have to keep column size 9 inches. So minimum is 9 inches. It might go more than 9 inches, but not less than 9 inches. So that's why majority of occasions you'll see like column sizes begin with only 9 inches. So this depth actually be depending on the loads and the moments, right? So even this change would be like 3 inches change. 12, next is 15, next is 18, next is 21, next is 24. Add 3 inches to it, because adding of 3 inches will have a flexibility in centering or shuttering materials. That you'll see practically. Now, there is a great recommendation also. When you are designing like G+2 or G+1, so you can try or usually 230 by 300 column sizes or 230 by 375 column size would be sufficient. So it is given like, though it is given like 230 by 300 size, but it is recommended to use at least 230 by 375. So it is a straight away suggestion. It is a straight away suggestion. In fact, these areas are unlocking key areas, right? So how do you design it? Why are we taking so much of time to design it? Because we are randomly selecting some random size of the members. We are analyzing it and finding many members are getting paid, and we are not taking effective decision to fix up the member sizes, and we choose another random number and apply to it, and again that gets failed. Sometimes that becomes uneconomical, and then you design it, redesign it, design it, redesign it. It actually takes a lot of time. So that's why you need a key suggestions. Like for finalizing the member size, especially for column, it is a clear statement. If it is less than G+2, try with 230 by 375, that would be fine. Straight statement. If it is like G+2 to G+4, try with the different size like 230 by 450 mm. And it is like G+4 to G+6, try with the different sizes. like 230 by 450 or 230 by 570, 525 column size. Try these sizes, right? You can begin with sizes, right? So how to fix or how to standardize these member sizes will actually come based on experience. Of course, as long as we will also reveal such kind of a concepts in the next webinars. Plinth beam size also. Now column size is over. Next focus on the beam sizes. How to choose the beam size? If it is a plinth beam and the length beam, plinth beam obviously will take only wall loads and it doesn't take any kind of slab load. If that is the case, we can have a lesser size, like begin with only 230 by 375 when we have a span less than 15 feet. If we are having a span little more than 15 feet, you can change like 450 mm. Though I'm mentioning like you can change to 450 mm, I don't personally take it unless the span is more than 20 feet. If it is more than 20 feet, then I prefer 450 mm. Otherwise, I prefer only 230 by 375, even if it is up to 20 feet. Plinth beam level, plinth beam level. Plinth beam, because plinth beam level will not have any load. It will have only wall load, no slab load, no light load, nothing. So that's why though span is a little higher, you can take the little cross section to it. So suggested sizes you can try with the 230 by 375. If it is less than 20 feet. And then floor beams, you try with this thing, like up to this one. So 15 to 20 feet, you can try this size. And if you're having a span like up to 15 feet only, column to column distance is less than 15 feet, you try with only 230 by 425 beam size. And this 125 is slab thickness. Means I have a beam slab and then beam like this. Right? This is like 125 thickness. And this is like web depth of beam. So together both of them would be like 425. Out of 425, 125 is slab, and then this is clear web. This clear web again would be multiple of 3 inches, like 12 inches, and then 15 inches, and then 18 inches, and then 21 inches, right? That actually is based on the centering material or shuttering material, right? So now in our case, it is clear that we can try with this size, 15 feet, and then we can try this one also. 230 by 500. And the slab thickness, majority of cases, you try only this size, like 5 inches or 125 mm thickness. See, based on this simple guidelines which are shown on this screen, would actually make you confident enough to complete your design very quick. And moreover, if you can take the member sizes based on the suggestions or guidelines given on this, so member failures during design would be very minimized. So those will be very minimized. You have to minimize those designs. Automatically those will be minimized. Right now we are aware about this structure, analysis, design, reading of architectural drawings, column positions, and then beam sizes, standard column sizes, assumed column sizes for G+2 buildings. Such information is now clear to us and ready. Now we need to design it. Right? How to design it? So we are going to now design this. So before designing it, now let's see. 1 second, please. 1 second, please. Yeah, thank you so much. We are left with another 20 minutes. Let's try to fix it or finish it. Okay. Right. See now we are clear. Now we know this everything. Now next thing is we need to know the column to column distance. Now we know here is a column, 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 column, and then column again, column again, column again, column again, and then column again, column again, column again. Right. So you need to know the distance from this point to this point, which is like 17 feet 3 inches. From here to here is again here to here is again 13 feet 6 inches. And similarly here column to column distance is 13.5. Again here to here is around nearly 14 feet. And then here to here is again nearly 5 feet. From here to here is again 8 feet. From here to here is 4.5 feet. Right? These dimensions are dimensions among columns need to be first identified from architectural drawing, AutoCAD. Go to AutoCAD, make a grid line, find out the distance among all the columns. so that now we are ready to prepare a model in Staad Pro. Now we are ready to prepare a model in Staad Pro. Now I'm going to open this PDF copy to prepare a model, right? Let me just go to Staad. One second, I'm now going to this. So let me go to this and then now this is more clear. So we have a column to column distance of around 17.3 inches, 13.3 inches, and we have now go to Staad. Let's now go to Staad. So here I have a icon. Staad is now open. I go to new project. I'll keep space. I'll mention duplex. March 5th. So I'm going to keep this units in feet and inches. I'm keeping in foot now. I'll say okay. Somewhere actually it is getting saved. Let it be. I'm going to say finish. So basic information, we just have clicked on this Staad Pro and then keep this name and then fix this unit system. And very quickly, this will be displayed in isometric view. So this is a grid based. So grid is displayed here. I'm going to turn off this grid. I'm clicking on this. Let me click on this so that the grid will be closed. And if you want to see this back again, so this is grid is back again, and I'm clicking on this geometry. So before we are directly preparing this model, you should know that we have nodal cursor, beam cursor, and we have different cursors here. And we need only beam and then nodal cursor because we don't have a plates in our model. And this is actually main tabs that we have here. By using these tabs, we can make a complete procedure from model preparation to application of loads, analyzing it, load combinations, and then design it, and then find out this member failures also. And here we have a views also. Like we have front view, back side view, left side view, right side view, top view, bottom view, isometric view. How do I come to know it? So it is depending on the color. So this cuboid is colored at the front face. So it is front view. This is colored at the back side view, left side, right side, top, bottom, isometric. Right? Now actually we need to go to the plan view because we have a plan details. So obviously every architecture drawing will be on plan view only. So I go to this icon, last but 3 icon. So here I have this one. Sorry. So I go to this. So I go to this. This one is plan view. Click on plan view. I go to this one and let me turn off this. Yeah. So when I go to this plan view, obviously when you check on the left bottom, so here we have a coordinate system like x-axis, bottom, this is z-axis, upward is y-axis. Now I need to create first node, which is like this. Let's get back to this one. So this is the first point. This is the first node or first column, second column, third column, fourth column, fifth column, sixth column, seventh column. So let me say, as per Staad Pro, this is x-axis on plan view and z-axis. So this is x-axis and this one. So this actually refers to positive direction. This also refers to positive direction. Means if you want to create a node here, this is exactly 0 point. So we have to create a node exactly at 0 point. This is 0, 0, 0. And then we are going to copy and then paste here with a distance of 17.3 inches, which means this way, right? This way. So since it is this way, this is a positive way, positive x direction. So copy and paste it. You take this, copy and paste it this direction, which is again x direction. And when you are selecting these 3, 1, 2, 3, and pasting this direction is z direction. right? Now we have to select Z direction, positive direction. But if you are taking all these columns and then pasting this direction, this is again Z, but opposite to Z direction. So you had to indicate minus sign to the number. For example, when you are copying and pasting and then 10 feet distance, you always have to mention like minus 10 feet. This is Z direction, but opposite to Z direction. So it is minus 10 feet, right? Likewise, we have here. So similarly, now we have one column, second column, third column. I'll keep this on the right side for easiness. I'll keep this tab on the left side. Now, let me keep this on the left side. I'll go to this point. I'm going to here, type 0, and I turn off this point. Sorry. Now I'm going to here, 0, enter. Now the node is created. So this exactly node is actually representing this first column, 0, 0, 0. Now next is this way. That is 17 feet 3 inches. Or you can consider either 17 feet itself or 17.5 feet, right? So now what I do is I'm using node cursor, select this, copy paste it, X direction, 17.5 feet, nothing but 17.5. I'll say like this. Maximize this to the first column, second column. The second to third column, how much distance it is? It is like 13.5 feet. So I'll select this, Control C copy, Control V paste it. So it is again 13.5 feet over, 3 columns over. Now I have again same place. When I have this and this in the same place, this and the same place, and there is a change between these two, right? So what I now do is I'll take these two also. I'll take these two nodes, copy paste it, Control C copy, Control V paste, Z direction, space is 13.5 feet. So positive 13.5 feet, done. Now I'll take this node from this point to this point, the distance is how much? From here to here it is 13 feet only, right? So I'll go to this. Let me say from this column to this column distance is how much? 13 feet only. So I'll select this, copy paste, left side now minus 13 feet. This is done. And again, from this column to this column distance, from this point to this point, this distance need to be known. From here to here distance is how much? So from here to here dimension is around 6 feet 9 inches. From this point to this point, it is 6 feet 9 inches. So I'll say like, and of course, this is a foundation layout. You cannot find it, but you have to find from this only. You have to add this point to this point, which is like 6 feet 9 inches. So I'll say like copy paste minus 6 feet 9 inches in the sense 0.75 feet. I need to mention minus 6.75 feet. Now it is over. Now I add these columns. Now I need to add these columns. Distance from here to here is around 14 feet approximately. I'm going to take these two, copy paste, Z direction, approximately 14 feet. It is done. It is now done. Next, I'll go to this. Now I have this also, this and this, not at the same place. So there is a little gap between these two. So technically you can give on the same place, same point. Since gap between these two is too lesser, it is around 9 inches only. So you can copy paste it on the same line. So distance between this and this is how much? From this point to and this point. What is the distance? You check the distance from this point. So it is like 14 feet and then it is like 5 feet. 14 plus 5, it is almost 19 feet. So I'll take these two, copy paste it, Z direction, approximately 15 feet. Sorry, 14 plus 5, 19 feet. Control Z, select this, copy paste, Z direction, 19 feet. Over. Again, now I have 2 more columns here at the same point. So I need to know the distance between these two. The distance between these two is clearly given here. 8 plus 4, 12.5. I'll take this 12.5. Right. How about this? It is 8 feet only. And this is something different in the sense this is like acting on different point. But let me still say from this point to this point is like from this point to this point, it is 8 plus 5, 13 feet from here to here. and the distance between these two from this grid to this grid need to be known. So what is the distance between these two? It is 2 feet 9 inches. So I'll go down 2 feet 9 inches. So I'll take this node, copy paste it. This is a minus 2 feet is 9 inches, nothing but 0.75 foot, and then Z direction is 8 feet. That's all. Right? Now nodes are created. Now nodes are created. Now I'm going to use isometric view. I'm actually going through this procedure just to let you know how to create it. It doesn't mean that each and every step is going to be discussed, but you need to know how it is going to be done quickly, right? So I'm going to select this, copy and then paste them, copy, paste them. I'm going to select like this, Ctrl+C, copy, paste them. Now I'm going to paste it down, minus 8 feet for foundation level. So all this I'm going to use front view. This is a foundation level and this is a plinth level, right? Now what I do is I'll select all this like this. Now create, I go to geometry, connect beams, y-axis. Yes, means columns are created. I go to again front view. This is a plinth beam level, isometric view, geometry, connect beams, x-axis, okay. Again, geometry, connect beams, z-axis, okay, this is done. And since this node is not exact at this point, in the sense not in line with any node, this is not getting connected. But still you can make by using some options here. You have to go to this icon, press it, hold the mouse button for 1 second. So you'll get a multiple options. I'll go and then take last option. This last option actually gives us perpendicular beam option. Go to this, select this, done. And then go to this, select this, done. If there is any change required in the model, we can make change at any point. Even something goes wrong, don't worry, we can make any changes at any point. That's a good flexibility that we have with Staad. I'll take this perpendicular, select this, done. Right? Now plinth level is over. Now plinth level is over. Now what I do is, not this is plinth level is over. I need to go to this architectural drawing. I need to go to this architectural, because we have to definitely give a beam where we are having a wall. For example, or otherwise, let me open. This is a ground floor plan. So I'll add let the beams accordingly. Means wherever we have a wall like this, we have a wall here, we have to add one beam here, means one beam you need to be added here. And then you need to add one more beam here. This beam is actually representing this wall over, and you have to add one more beam here, right? So you have to continue this like this, and then you have to make sure that this is actually we have a one more beam here. So here we have to add one beam for staircase resting and continue the same beam for puja room also, add one more beam like this, right? Now we need to know the distance between these two. To add it and to create it, we need to know the distance between these two, right? That will come to know. Let's see what this value is. So it is exactly almost the same value that we have here is like 5 feet. So from this point to this point is approximately 5 feet. So what I do is I'll go to this Ctrl+C. What I do is I'll first go to this one, select this, right? Now I'll select this, this, Control C copy, Control V paste, X direction, -5 feet, say okay, this is done. So this actually, this is representing this beam, and this is representing this beam. And here we have continued it, and there is a one more beam here, means here. So we have to add one more beam in here. So I go to this, hold it, use this icon, click like this. Right, this is for puja room. Now this is over. Now what I do is I select the same thing. Now the height of this floor, height of this, this model is for 8 feet. So I'll go to this, I'll select like this, copy paste it. I'll say Y is 8 feet only, but floor to floor originally is 11.5 feet. Means you need to add 3.5 feet extra. I'll select this node. I'll select all these nodes. I'm pressing F2 to move the nodes. I'm changing like Y direction 3.5 feet. 8 plus 3.5, that is 11.5 feet. Say okay. Now we have created one more floor at this level. We have created one more floor. I'm sorry, there is a sudden drop in the internet. Now again, we are getting connected back. So I kindly wait for hardly 1 minute. Yeah, let's now begin. Yes. Is this clear now? Can you just your response once? Is this clear? Okay, now let's begin again. Now it is done. Now I need to create a model. Thank you. Thank you so much for your response. Yeah, now it is clear. Now, first floor is already created. In the sense, ground is now created. First slab, which means ground is now created. I'll go to this use front view. I'll go to general and add support to it. Go to support, create a support. We have a fixed support. Add here. Select this fixed support. Then select bottommost nodes. Assign. Yes. So when I go to this plan view, it is very clear that we have supports or we have columns here, right? Yeah, actually we are going to send this recorded video. We are going to send it to you after the session is over. In a sense, there is a separate link that I'm going to share with you, and that will be valid for some time. That will be valid for a very limited period. So you can just go through this video again, no problem. So since actually we have a kind of a challenge, we are trying to fix it or finish it. Okay. Okay. Then I'll make it very slow. I'll make it a little slow. Sure. I can make it this slow. So now it is clear. Now we are at the plan level. I'm using Shift plus K shortcut key Shift plus K shortcut key. I'm going to keep in isometric view. Isometric view. I'm using this beam cursor. Go to front. Now I need to go to front view. Select this beams. Press Control. Select the columns also. Alt. I'm pressing Alt. V plus V. I go to plan view. Right. I go to plan view. Now I need to check the floor beams, ground floor beams. First floor beams based on the walls arrangement. I will go to this. I'll select first floor. So this is the first floor plan. I'll use Staad. Right. Let me now go to this. See here. So here what happened? Here what happened? We have an additional beam here. We have an additional beam here. So we have additional beam. In the sense, this beam has to be here, right? And this beam will be continued. And here we have a no beam because we have no. Here we have a no puja room wall. So this has to be avoided. And we'll have this beam little extended. This beam is little extended here. So we'll take this beam and then extend it. This beam is little extended. So rest of the things are absolutely fine. Then this needs to be provided. And of course, we have to create one more beam here for this one beam. And then this can keep remain same. Continue like this. And then this also, this is not required. And this is also not required. Right? So what I now do is, I'll go and select this. Delete them simply. Over. And now I'll extend this. I'll go to this perpendicular beam option. Select this, come to this point, select this point. Now I'll take this beam also. This is actually 5 feet from here to here. Okay, I'll now select this, pressing Control, select this, copy paste it, 5 feet in this direction, nothing but Z direction, minus 5 feet. Right? So now when we see this here, we have a one node or two beams. Here also two beams with one node. I'll select like this. I'm pressing Control, select like this, and I go to this geometry and then merge. I'll merge this member, close it. So now this unnecessary node has been now removed. Here and then here. In addition to this, you have to actually extend this beam. Right? If you can get back to this, we are not having a beam at this point. We have a beam at certain point. Right? Let me say it is almost 2 feet. It is almost 2 feet. I'll select like this, copy it, paste this, X direction, minus 2 feet, because we are pasting an opposite X direction, paste this. Right? An isometric view. Now I'll select this first option, select this, and then add a beam like this, use beam cursor. This beam is not required, delete this. I'll go to plan view and I'll select this and then geometry, merge this member, say merge, okay. Right? This is now done. This is now absolutely done. See, here we have a bathroom wall. Done. And here we have one more bathroom wall. Done. Staircase beam. It's done. And this beam is a little extended. This is also done. Rest of the things are remain same. Now it is clear. Right? Now it is clear. I'll go to whole structure, isometric view or elevation view. I'll take now up to this extent. I'll say Control C copy, Control V paste it. Height is 11 feet, 11.5 feet. Say okay. Now model is ready. Is everyone facing the same situation? There is a suggestion from Sunita A and then Tivakar. Okay, let me make, yeah, no problem. Okay, no problem. I'll make this. Okay, I'll make it little slower. I think there might be some kind of a struggle, technical problem absolutely with this internet connection. No problem, no problem. We'll not fix it, we'll not fix it. Okay. Now let me say, let me make this session a little more slower. Now see here, I think now this model is now prepared, not fully, but we need to make this one also staircase model. In a sense, staircase support also has to be provided to this. And before making this a staircase support, I need to explain you how this staircase arrangement can be there in the Staad Pro. I'll go to plan view. Now I'll go to this. Here we have staircase. Here we have staircase. I'll click on right click, mouse right click, new view. Okay. Isometric view. Right? So this is where actually we have staircase. So technically we have a staircase. We have a staircase like this. I'll show you how it is. So we have a staircase like this way. Done. And then again, we have a kind of a landing here. And then from here, again, we have a landing somewhere here. We have a landing here. So we'll connect like this. Again, this is going to get connected to this level. Right? So we have to do this. So we should know we have to create a beam here and then beam here, again beam here and then beam here. So we should know this height and we should also know this height. So how do I come to know this height? So this height we come to know from architectural plan. One second. Yeah, now see, now we have to create a mumty room also. Mumty room, nothing but a staircase headroom we need to create. That we can make it anyways, right? So now this staircase is like this, and we'll have an additional level here. Mumty room, nothing but staircase headroom. So we have to make like this, right? So now for this height, we are assuming height of this one is like 9 feet only. So height of this floor is, let me say it is 9 feet from here to here. So even if it is 9 feet, initially you have to copy this entire thing, paste it with 11.5 feet only, 11.5 feet, and then reduce height. I'll show you how it is. So now I'll go to this. I'll go to front view. So I'll select like this. Copy, paste, Control C, copy, Control V, paste. Height is 11.5 feet. Right? This is fine. Keeping in the isometric view. Now this is an extra node. I'll select this. Merge geometry. Go to merge. Close. Now we need to make additional floating column here. We need to make additional floating column here and then here. So that staircase will have a 4 columns. Otherwise, if you don't keep any kind of a floating column here, then this will act like a true cantilever. This also will act like a true cantilever. Then these columns will be will attract much bending moment. So and automatically that will be over designed. So that's why I need to go to this again, this option, click here, add here, click here, add here. So floating columns have been now added to this. Not only this, we need to add supporting beam to this layout, this open mirror staircase. So go to this plan view. So how do I come to know the height? So I can come to the know height of it from reading of this architectural plan. Go to this. I'll say like plan. So see here. So how many steps we have here approximately? So here we have 7 steps. Here we have 16 steps. Usually we'll have a step like this, right? So this tread is 1 foot, riser is 6 inches, nothing but half foot. 6 inches is nothing but half foot. So 7 feet in the sense, 7.5 is how much? 3.5 feet. So here we have a beams, supporting beam at 3.5 feet and 16 feet, 16 steps. 16 into 6 inches, nothing but how much? Nothing but 8 feet, right? Nothing but 8 feet. Half of 16 is 8 feet. Half of 7 is 3.5 feet. So at 3.5 feet, we have 1 beam here. And again, 8 feet, we have 1 more beam here, right? Now I go to this Staad model and create mid-landing beams at 3.5 feet and then 8 feet also. Now I'll select this node, Control C copy, Control V paste, Y direction upward. I'll say 3.5 feet positive. Node is created. Now I'll select the same node, copy and then paste it. Landing width is around 3 feet or 3.5 feet. I'll say 3.5 X direction. Again, copy paste, Z direction, minus Z direction, 3.5 feet again. This is fine. Now we have created one mid-landing beam. I'll go to this beam cursor, add, create it. Similarly, I have to go to this also, select this node, copy paste, Y direction, 8 feet height. Now node is created. Select this nodal cursor, select this node, copy paste, X direction 3.5 feet, Z direction again 3.5 feet, copy paste, Z direction 3.5 feet. Now go to this beam cursor, select this one, select this one. Now clear. Now I have staircase like this, over, again staircase like this, over, again like this, right? So we have a staircase like this. Yeah, I think it is on full screen only. It is now full screen. Right? Now what I do is, now I straight away, now I go to and select this, and then this. I'll select this, or otherwise, floor to floor height is how much? It is only 11.5 feet. So I'll say, I'll select this, copy, paste, floor to floor height 11.5 feet. Now I'll say like 11.5 vertical direction. So automatically in the next floor, in the same position, this mid-landing beams will be created in the model. Mid-landing beams will be created in the model. That's all. Now I'll say, now I'll just go to this whole structure to see all this entire model. I have to go to whole structure, icon is here. So I'll go to this icon, and then I'll say, click on it. Now this entire model is here. Now entire model is here. That's absolutely fine. Now I go to this properties, nothing but beam sizes, column sizes, right? Now since when we are preparing this model, we actually put this unit in feet and inches. Now I need to change its unit system to meter, for which I need to go to this icon. Go to this icon. So I go to this icon, click on it, change units to meter. I'll say okay. Now I can go to this dialog box. Now I can have to define it, go to rectangular, and we know the column sizes we are giving like 375 minimum, width is 230 anyways. I'll say add here. All the columns will be at the same size. Now again I'll go to print the beam. Print the beam will also be having the same 375 size. Okay. And the remaining floor beams, I say 500 based on the thumb rules that we have studied. Again, I'll keep one more 500 for next floor beams, means ground floor beams and then first floor beams. Now it is over. Now first one is columns, plinth beam, first floor beams, second floor beams, and next headroom also you can create one more the same size, 500 depth including slab, and then 230 the width of the beam. Say okay, and then close this. Now I have to go to select this column sizes first. Select this column sizes. I'll go to this select. I need to select only columns. So go to select, and then beams parallel to Y direction. Then only columns will be selected. I'll click right click, mouse right click, new view. Okay. Now all the columns have been selected. I'm zooming in. I'm selecting this. make a box, select all the columns in this window. I say assign, yes. Now all the vertical members have been assigned with 230 by 375 property. Now I need to see this entire structure, for which go to this one. And again, I'll go to front view. I'll select only plinth beams at this level, right? Right click, new view, or otherwise, I'll select this property, select this all these plinth beams at this level. I'll say assign, yes, over. I'll select this, I'll select another floor, I'll say assign, yes. Next, I'll go to this, next, I'll go to this, okay? And then I'll say assign, yes. Next, I'll go to this and select this, assign, yes. Likewise, we have to create a properties. First is for columns, second is for plinth beams, third is for ground floor beams, fourth is for first floor beams, and then the fifth one is for terrace beams, headroom beams, right? Now there are some beams like landing beams are not assigned with the property. And if you want to select landing beams, it is a little difficult to go into this model and then select it. But of course, we know that all these landing beams are not assigned with property. So I use a different option. I'll go to this select. I'll go to this last but one option by missing attributes. When you go to this missing attribute and select any option, so automatically elements which are not assigned with the property will be selected. In our case, landing beams are not assigned with the property. Selected. So only landing beams are now selected. I'll say assign, say S. Now this is done. Now this is completely done. Modeling is now prepared, and then properties of the columns also have been now given. Properties of the columns also now has been given. Now what I do is, not only this, we have to focus on the column orientation. Column orientations. So I'll select only columns beams parallel to Y direction. Sorry. Select beams parallel to Y direction. Right click, new view. Say OK. I'll go to plan view. For time being, I'm turning off columns. Turning off supports, for which I'll say shift plus yes. I'll say shift plus yes. And I'll press control plus 1. Control plus 1 for column orientations. By default, all column orientation, columns depth would be parallel to x-axis. Means all the columns would be this direction only. All the columns. You can take any column. This column, this column, this column, this column, this column. Every column orientation will be, depth would be parallel to the x-axis. So now I need to go to this orientation of the columns and change this orientation accordingly. Where can I see this? I have to go and then see architectural drawing. I have to go and then see in the architectural plan. So I go to this. So let me keep it on the right side. This one. So I'll keep it on the right side. I'll give this a Staad mode also on the left side. Then see this one. See. Now all of them are horizontal. So how many are vertical? So this is horizontal. Horizontal means this matching. Tick, tick, tick. And this is a floating column. Ignore it. So this, and this is changing. This is changing. Remember it. So again, this is fine. This is tick. This is changing. So this is again changing. Right. Next. This is also again changing. And this is also changing. This is also changing. And this is also changing. How about this? This is absolutely fine. This is a floating column. Ignore it. So out of all, now the thing is vertical, 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 vertical. So 1, 2, 3, 4, 5, 6. 6 columns are having vertical positioning. The reason is if you can keep this column inside of it, then this column may be visible in the bedroom, living area, or bedroom. That's why intentionally this is now flush with the walls. The same thing for this also. Same thing for this. For this, there is no reason. No reason in the sense either I can keep here or keep here also. No problem. Either way is absolutely fine. Even this one also keep here or this one also. But if you can keep this one, But if we can keep this one, for example, if we are keeping a door here, we are indirectly wasting this space, right? Because we have a column here. We have decided column, we need to keep additional layer of brick wall and then start connecting this door to it. So to use such kind of at least 3 inches, 4 inches of space also, we can change its orientation. So we can use our space very effectively. So that's why now 1, 2, 3, 4, 5, and then that's 6, right? This one also for all of them. Technically speaking, you can change its orientation also. If we can keep this orientation like this, then you'll have enough space for ventilator also, right? So I'm going to change this also. So for which I go to again property, maximize. Let me minimize this. Maximize this complete stand. I'll go to beta angle. So here I have option beta angle, create beta angle. I'll keep like 90 degrees. Select this 4. I'm pressing control. This one also, and I'm changing this also. Like this. Assign. Yes. Now I'm pressing control 1, column orientation. See here. This, right? I think this is not required. 1 second. Yeah, this is absolutely fine now. This is okay, right? Column orientation is also now changed. Now control 0 to keep in the original place. Shift yes for turning on support. Now model is clear. Now what happened is I need to go to load and definitions, go to load case details, add load case details. I'll say dead load, add. Again, I'll say add live load, add. And here I'll go to load combination also. I'll create load combination right now. Go to load combinations. Load combination is 1.5 times of dead load plus live load. 1.5 is the factor of safety. 1.5. Transfer all of them into right side. Right? I'm copying it. I'll say add. I'll create one more load combination without factor. I'll say 1 times of dead and live load. Transfer all of them. Add. So with this, what we did is we have added 2 loads and then 2 load combinations. This load combination is for strength check. This load combination is for deflection check. Or we can take the reactions also for foundation design from 4th combination, unfactored load combination. So this is how we have to create a load means. Now we need to add loads to it. So I go to this dead load, add. First thing is you should add sulfate to it. And then second thing is go to member load. Member load is 16 kilonewtons I'm adding. I can get back to this. This wall load is 16 kilonewton per meter that you can see from this load calculations. See here. Load, how much load it is? 16. And the second one is 8. Third one is 4.5. Nearly. Right? We are focusing only on dead loads and live load for this session. So we have to focus on this dead load 16, external wall, 8 internal wall. This is parapet wall. So now I go and then add all these loads. Go to this. Sulfate is added. Add 16. Add 8 also here. Add 4.5 also here. These loads are of only wall loads. Now I go to select sulfate. Assign to view. Assign. Yes. Means now structure is assigned with this sulfate. Now I'm selecting this 16 kilonewton per meter. Go to this front view and then use this ground level and find out where we have external walls. Alt VV. I'll keep it in the isometric view. Right? I'm using arrows like this. Now this is external wall. Press control. External wall. External wall. External wall. External wall. External. All this periphery. You'll have a maximum thickness of wall. I'll say assign to beams. Assign. Yes. Right? I'll select this and I'll select the rest of the beams. Right? To minimize the scaling of loading, I have to click this icon and then automatically it is adjusted. I'm just using mouse and then control and then mouse scrolling. I'll take this load, select this, select this, select this. I'm assigning all this internal wall to this entire structure. Done. Right, now I go to next level, front view. Similarly, select this one also, and then select all these columns, Alt VV, isometric view, or I can say plan view. Same way, I'll select external wall, this. Don't drag a window, select only on the beam. Assign, sign, yes. Select this. I'll go to whole structure. Again, plan view. I select this. I select this. Alt VV, isometric view. And this is a parapet wall. Click on it. Click on it. And here we have an external wall this way, this way, this way, this way, this way. Assign because this is a staircase wall. Over. I go to whole structure, plan view. I select only staircase. Right click, new view, OK. Now let me say, I need to add this load, staircase load. This is staircase load is here. See here. Now I need to go to this staircase load. How do we have a staircase? We have a staircase like this. Right? Now you know it's the first flight. In the sense, you know the thickness of the slab like of 150 mm. So 150 mm, RCC density is 25. You'll get this load. And step weight, height is this, length is this, half BH. You'll get step weight 0.456, sorry, 0.56. And floor finishes like 2. I mean, approximately we can say 1.5. So sum of all those loads go nearly 6. So length of this one from here to here, length is approximately 6 meters. I'll show you on Staad file. So total load multiply this span divided by half. Half load on the right side, half load on the left side. So this one is around a 9 meter kilonewton per meter, and this one is 15 kilonewton per meter. I'll show you other one. Okay. Right now, I'll show you the same thing here. So I'll go to this. You can see the same dimension here. I'll select like this. And let me say up to this approximately 2.6. Now I'm taking like 6 meters, 3 meters approximately. 3 into 6, 18. 18 by 2, 9. Again, from here to here is 4.5 meters. I'll take like 5 meters only. 5 into 3, 50. Yeah, it is, I think, 5 into 6. 30, 30 by 2, 50. So I'll add 9 and then 15. Dead load, add, member load. This is like -9, first case. Again, -15, second case. Close this. This one, I'll select here, here, assign, yes. I'll select this, here, here. Sorry. I'll select this. This is going to act on it. And this 15 is here, and then here. Similarly, this 9 is here. So I'll say again, select this. $15 here and then here. Technically speaking, you are supposed to add this load even here also, here and then here and then here and then here. But what we did is we have in fact assigned with 16 kN per meter now, considering that there is a wall, or at least this one. So that's why we are avoiding adding this load. Right? I'm going to pole structure. I'll go to this dead load, add. Now I need to add floor load. Now. So to make it quick, I use this command. Click this. It is 3.5. I'll click this height. It is like 10.10.5. So right, I'll say like minimum wire range is 3.5. Maximum wire range I'll consider like 11 meters. Let me click again. It is 11 meters. So slab weight is 5.125. I'll say add and then close. See, now slab load is assigned. So what we are doing is we are using a very quick way. So we'll take a minimum wire range, maximum wire range. We are not bothering about X and Z ranges. So if you are not considering Z, X and Z ranges, automatically Staad will take and apply load on every on every beam. Actually, slab panel surrounded with beams. So we are fixing this minimum value and then a maximum value. So automatically everything will be loaded with the 5.125 load, which is off slab, right? Which is off slab. This is fine. Now what I do is I'll go very similarly with this live load. Add. I'll directly go to floor load. I'll say live load is 2. I'll go to this value like 3.5. Height I consider like 11 meters. Add. Close. That's it. Live load is also added. Though we have openings in the slab, automatically it will take full loading. So since it is a quick design, you have to be, accuracy level will be little deviated, but still it is not going to affect our design. It is not really going to affect our complete design. So if you have to make it very quick, you have to do this pattern. Now dead loads and the live loads have been added to this structure. Next thing is you need to design it. For designing it, you have to first analyze this, go here, add here, close this. Now analysis is done. In the sense, option is added. Now I need to give load list to this. Load list in the sense, you need to select a particular load combination for which structure has to be designed. Otherwise, Staad will design this structure for all the combinations. So I go to commands, loading, and then I'll say like load list, right? Commands, loading, load list. Next, I'll select only this factored combination. I'll say okay. Means only for this combination, Staad has to design structure. I'll say okay. Now I go to design parameters. I'll select concrete here, and then I'll go to this right side dialog box. I'll select code book here, IS 456. Then I'll select the parameters, transfer all parameters to left side, select required like grade of concrete, grade of steel, grade of secondary steel, and I'll go to this torsion, not to consider torsion, transfer it. Okay, 1, 2, 3, 4 items. Okay, define parameters. Grade of concrete we are considering 20 only, 23 euros to convert into kilometer per square meters. Add it. FI main, I'll say 500, 1, 2, 3 to convert to kilometer per square meters. Secondary, I'll change again 500, 1, 2, 3, add it. Torsion, ignoring or neglecting torsion, add it, say okay, and I go to this commands. I'll ask Staad to add design beam, design column, take off for estimation of steel and then concrete, close, scroll this down, select this, assign to view, assign, yes, again select this, assign to view, assign, yes, assign to view, assign, yes, assign to view, assign, yes, and then select design beam, select only beams. So select beams parallel to x-axis, select beams parallel to z-axis. I'll say assign, yes. I'll go to design column. I'll select only vertical members. I'll go to select beams parallel to y-axis, assign, yes. Yeah, it is 500, 3 zeros. 1, 2, 3. Thank you. Right? So I'll explain you now. So what happened now, the procedure is, we have created a model and then we have added properties, assigned those properties. Properties nothing but cross sections of the members, beams and then columns. For columns, we have assumption. For beams also we have assumption. And then we created a model. We went to this loads and then we went to this loads. We have added loads also, like dead loads and live loads. Under dead loads, we have added external wall, internal wall, parapet wall, staircase load, floor load or slab loads, over, right? Yeah, we will discuss about it. We'll discuss about ELX, ELL. 1 second, right? So now this is the case. Next is now select a parameter. Next is a design step. So we need to go to, before designing it, we have to inform Staad to take load combination, only factored combination, and then we have to go to design parameters like giving grades of materials. What kind of a grade of material we use? 20 grade and then 500 grade of steel. And then we have to inform Staad to ignore torsion. If it is a local torsion, like when we have a cantilever slabs, then you can consider torsion. If otherwise, you don't need to consider torsion here. So that's why we are neglecting torsion here. And then we have to inform to the Staad also which member has to be designed like a beam, which member has to be designed like a column. Because Staad doesn't know. Staad knows only model. It knows it is an element. You have to inform to a Staad, it is a beam, it is a column. Then you have to go to this commands, add it, design beam, design column, select, assign this parameters to it, and then now you can analyze and then design by using this option. Analyze option is available on this bar. So you go here, analyze it, run analysis, yes, done. So there are 20 warnings. There are 20 warnings. I had to go to this post-processing mode or view output file. Sorry, let me go to view output file. Find out if any member is failed. So I'll say done. Results or warnings. See, it shows like only length to depth ratio. So on so is less than. Means what actually Staad does is, there are some beams whose length to depth ratio is less than 2.5. So it is just giving us a warning. It is not saying it is failed. It is giving a warning like it is considered like a what do you say, D beam. It is considered like a D beam. So it is giving a warning whether it is a D beam or normal beam. So either we can avoid this warning, or if you want to eliminate this warning, we have an option. We have to first note down all these numbers. Right? I'll note down all these numbers. Let me say, I'll go to this. I'll take any text here, new. I'll say like text document here. Let me say, click on it. I'll keep it on the right side. I'll go to this Staad output. Now let me type. Number is how much? 17, 25, 33, 43. So I'll say like 17, 25, 33, 43, 62, 65, 70, 95, 112, and then 115, and then 120, 120, and then add 142, and then 152, and then 153, 155, 156, 158, 159, 161, 162. Copy all of them, right? Now I go to Staad editor. I have a Staad programming option available. I'll go to Staad editor here. So whatever we made, model and everything, that is actually reflected in the form of program. So I'll go to last but one here. Here, I say like ENSH, enhanced shear strength. I'll give 100%. MEMB, members, paste all these member numbers. So what actually Staad does is ENSH, enhanced shear strength, 100% members so on. So means all this, for all these members, Staad will enhance its shear strength. Enhance its shear strength, then automatically these warnings can be avoided. Reanalyze it, check it. There is one warning, means still there is one member. Previously we had 20 numbers, 20 warnings. It is simple only, it is not really great warning. So what it says is, so length, program line is too lengthy, you have to split into 2 lines. That's it. It's not a technical warning. It is saying like 1 or more lines are too long and will be split into 2 lines. It is saying Staad is considering into 2 lines. Let it consider, no problem. But is there any member failed, for which I have to type Control F, find, and type fail. Type fail. If beam is failed, it shows beam failed. Next, column fail means adequate. Type adequate. Search for it. Is there any column failed? No. So no column is failed, no beam is failed. So conclusion of this discussion is, we are actually why these columns and then beam, our entire structure is passed, because we use thumb rules. Because we use thumb rules. We are actually suggested to use different column sizes for different number of floors. If it is like G+2, try with 230 by 375. Members will be passed. If it is beyond G+2 floors to G+4 floors, you change a different column size. That would be all right to use and check it. So there are some guidelines or something like key factors. Even for beams also, for plinth beam, use 230 by 375 up to so on so span. And for floor beams, use beam size up to this span. So since all of them are already given here, we try to use those guidelines and assign this structure, run this analysis and design it. So it is done. So what I'm trying to let you know is, in our day-to-day basis, being a consultant, day-to-day basis, we used to repetitively do the same thing. Every day we need to create a model, apply it, and then calculate the loads, apply on it, analyze it, design it. So what I'm saying is, wherever or whatever the key area is there in the structure, which actually makes us to think, which actually takes our time to work on it, you have to pay special attention and find out a easiest way to it. Easiest way in the sense, now we are finding out the easiest way by just based on experience by fixing up the column sizes. So how could we say that up to G+2 floors, so on so column size would be sufficient? How are you saying it? By experience. After you have worked on it for n number of times, and after worked on these theoretical things, after you have made n number of calculations, we have to on our own find out our own solutions, our own assumptions, which would be most realistic, so that we can minimize our time to design any structure. And this kind of a guess is not just for a only duplex building. We have such kind of a guesses for 5 floors buildings, 10 floors buildings, and then 15 floors buildings, high-rise buildings also. And we have such kind of a guesses to identify the steel also, which is required for columns, and as foundation sizes. What kind of a foundation sizes we need to take, right? Whether it is 6 feet by 6 feet or 7 feet by 7 feet, such grouping. In the sense, now I request everyone to pay more attention. For foundations also, you have to always fix up the foundation size for a particular SBC. For 200 kilonewtons per square meters or 20 tons per square meters, up to 500 kilonewtons, what would be foundation size? 500 to 750 kilonewtons, what would be foundation size? 750 to 1000 kilonewtons, what would be foundation size? 1000 to 1250, what would be its foundation size? 1250 to 1500, and then 1500 to 2000, 2000 to 2500, 2500 to 3000 kilonewtons. So likewise, you have to analyze and then design and standardize more important elements, which actually needs you to think every moment. Whenever you design a structure, you always have to think. You always have to think to fix up the column sizes, to fix up the foundation sizes. Trust me, for design case, beam case, you don't need to think every time you design. You need to think only for fixing up the column sizes majorly, and you need to think more to fix up the foundation size. That's all. So that's why here a key suggestion, most important suggestion or most important key factor is, you have to fix up the standard column sizes with the standard reinforcement for standard loads. Similarly, standard foundation sizes for SWANS standard SBC like 20 tons per square meters with the SWANS standard size, SWANS standard thickness, SWANS standard reinforcement. That you have to maintain for everything. So whenever you get SWANS reaction, you pick the foundation size suitable. That's it. You don't need to do design every time. Design remains same. As long as load is same, why do there is a change in the design? Up to 500 kilotons load that is transferred to the foundation size, that would remain same as long as the SBC is same. If SBC changes, footing size will change, thickness will change, steel will change. Likewise, so majority, the frequency of identifying the SBC of the soil would be like 150 or 15 ton per square meter, 20 ton per square meters, or 25 ton per square meters. These are very commonly identifiable SBCs that we are experiencing our day-to-day consultancy services. So you fix for 3 SBCs, 150, 200, 250, and then 500 kilotons load, 750 load, 1000 kilotons load, and then 1250 kilotons, 1500, 2000, 2500. That's it. There will be hardly 30 types. In a sense, hardly 10 types. Hardly 10 types of the foundations for different SBC. That's all. You need to work only for 10 times. That's it. You don't need to work every time you design. You might have designed 100 structures. You have to design the foundation for 100 times. Don't do that. You design it for 10 times for different loading conditions, and you use the same foundation, considering it as a grouping of foundations. Is this clear to everyone? I request you to confirm if the discussion is clear. That's it. Design is closed. I request everyone to respond on it. Is this clear to everyone? Can you please confirm?